Hello, bonjour, and welcome to the Don't Waste Water podcast. I'm your host, Antoine Walter, and in today's episode, I am extremely happy to welcome Sreenath BOLISETTY as my guest. Sreenath is the CEO and co-founder of BluAct Technologies, an award-winning spin-off of ETH Zürich that ambitions to trigger a revolution in water purification. In this episode, Sreenath will reveal how a single secret ingredient known by bodybuilders might solve an everlasting challenge for wastewater treatment processes. He'll share how, starting with an industrial target, he ended with a mission to improve drinking water worldwide. He'll also tell you how his technology might enter your homes very soon, and he will divulge how, beyond its core application, his technology also has many welcome side effects. If you're a bodybuilder like me, you certainly can't wait to discover what wisdom you owned without knowing it. Stay tuned, Sreenath answers that right after the credit.
You're listening to Don't Waste Water, the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
Hi, Sreenath. Welcome to the show. First, that would be great if you could introduce yourself. You are the CEO and co-founder of BluAct. So what is BluAct and what are you doing for BluAct?
Yes, I'm working for BluAct Technologies. We use milk protein fibrils for water treatment, especially wastewater and drinking water treatment. Even now, we want to treat water from the households as well. So, BluAct is a ETH spin-off company, and basically we use milk protein to do the water treatment.
So you mentioned that BluAct is an ETH spin-off company. Can you elaborate a bit on that and explain us how a company comes as a spin-off from the ETH?
Yes, the technology was developed at ETH during my postdoc career. Basically, BluAct is a technology-driven company from ETH. The patent was filed by ETH and BluAct took the exclusive license from the ETH on this technology. We are inventors, two inventors, me and my professor, Professor Rafael Mazinga. And ETH really supported us bringing the technology as a spin-off from the lab to the real world.
So that means that today your company still sits in ETH, or did you move out of the school?
Yes, we moved out of the school because ETH generally support its spin-offs for 3 years. Now we moved to Clark Park in Zurich because after some time we will be more focused on the business side compared to the research side because our products are ready to go to the market. So we just moved out of the ETH, but some instruments, technology sides, we have support from ETH as well.
So what sets you apart in this world of water and wastewater treatment? What is your secret sauce?
Our secret sauce is milk. It means from a cheese industry, whatever is left over from the cheese making, it's called whey protein. In German, they call it as Molke. Our secret ingredient is really the Molke. And normally this whey protein, even the bodybuilders, when they want to build a body, they really use this whey protein, which is available in the market from the fitness centers, sports centers, and from everywhere. So our secret sauce is really that milk protein. And we do some kind of nano engineering of this milk protein in the denaturation process and make it more stable. And then these protein fibers is our active component in the filtration process, especially in the adsorption of heavy metal ions. We also bind these protein fibers to the activated carbon so that you not only remove heavy metal ions, you can also remove, because activated carbon is well known in the water treatment industry. And it is like a matrix to hold our protein inside this activated carbon material, so that we can remove color, odor, and also like organic pollutants from the water treatment.
So you made for a smooth transition into our deep dive of today, which is really to go into what your technology really is and what it does. Actually, that's the beauty of an audio show, is that I can tell that I'm a bodybuilder and that I know whey very well because I have so much muscles. It's not true, but I can tell it. But how did you came to the idea that there is value to extract from whey?
During my postdoc at ETH, I was really using these milk protein fibers for the inorganic nanomaterial synthesis. Okay, these protein fibers have binding sites which can work as a reducing agents, as a dispersing agents. It can convert the metal ions into the metal nanoparticle. We have one other patent on it. It's called gold crystals making by protein fibers using the whey protein. And we have a patent and we are planning to have a company out of it as well, but that is nothing related to BluAct. And during this process, we can convert metal ions, especially gold ions, to the gold crystals. And then one company, which is based in Austria, it's an electroplating company. They have, instead of gold salt, they have a gold cyanide. And they came to us and they asked us, you did it with using the milk protein, converting gold salt into gold nanoparticle, gold platelets, and real gold. Can you do it with the gold cyanide to gold metal? And then I was curious to understand it, why they want to convert this gold cyanide to the gold. And they explained me their problem. Because of cyanide to the gold, they cannot release this wastewater to the river.
Mm-hmm.
And then I understand it, okay, we not only convert this gold salt to the gold metal, but we can also treat the water. And because once we treat conversion of this one, the cyanide will also become carbon and nitrogen, so that it is also non-toxic. So I see the real benefit, not only converting a toxic waste into non-toxic, as well as a really an expensive material at the end. So there are two positives for it. And then afterwards I saw, means at the time I was trying to understand it, the metal ions problem in the water, especially in the water, wastewater and drinking water. There are several natural underground water pollutants, metal ions, as well as industrial wastewater having various metal ions, and there is no actual solution existed in a cost-effective manner. For example, we know reverse osmosis, it can remove everything, but for gold cyanates, converting into gold, which is not possible by a reverse osmosis. And then I took this challenge, and it was really very exciting and interesting. We work continuously, and we saw in our first shot itself, we can do a removal efficiency of 100%. And we repeated this experiment several times. And I know that this protein not only work for gold, it can work for many metal ions. I tried with silver, platinum, palladium, and then we tried to look at various heavy metal ions, including mercury, because at the time I understand that mercury was the pollutant in the lake. And because of mercury, some fish we cannot eat because this mercury will be absorbed from the insects to the fish. And if you eat this fish because the mercury is from the water, and then it will enter into your body and it will get accumulated in your body. So then it will cause some long range diseases. So then the real idea comes from, okay, we can treat the water by using milk protein fibers. We tried various pollutants, natural heavy metal ions, industrial wastewater ions, and also radioactive wastewater ions, so that we can use the filtration by milk protein fibers.
So just to try to synthesize that, if I got it right, you started by trying to recover some gold. So that was the primary aim. And by doing that, you found out that there was actually a need to treat the water because this gold was just not floating around. It was in water. And if you can extract the gold from water, you might be able to extract also the other heavy metals from water. And that turns out to be then a water treatment.
Yes, then I understand the water treatment is a big problem, and the market of this water treatment is so unimaginable comparing to recovering of metal ions from a mining industry. And treating a water is because many billion people they don't have safe drinking water, and it also not only on the business side it will bring a lot of happiness, especially from the place where I came from in India. It's called Nalgonda in India, which is having a fluoride problem in the drinking water, and we have many of my friends have bone problems because of the drinking water. Then I realized I can find a meaningful career in my life because I grown up in a place where the water is not very safe to drink. So I like to work on water treatment sector.
So that's really a beautiful mission. I mean, that really makes sense. So if I get it right from what you said just before, you take this protein and you combine it with activated carbon. From your website, I saw that you have two different types of products. On one end, the membrane, on the other, the granulated medium. How did you came with these two type of forms for the product itself?
Because first we check the technology, how does it work? And then we know that milk protein fibrils can play a role in the water treatment. When we come to the customers, they have different requirement in the usage. Some people they prefer to use, they don't want to do major changes in the water treatment plant because they have their own constraints, everything is running. So initially we prepared these membranes. This is just like you need to have a filter press unit where you can put these membranes directly. Means if they have filter press unit, they can put the membranes. But not all the treatment plants doesn't have the filter press, but they use fixed bed reactors like granulated media, maybe sand media or activated carbon media or something. So then we thought, okay, if we can have a media which can be replaced with their existing media, so that it can directly used in the plant without any major changes. So then we developed and we focused on how to have a good granulated media, because basically you don't need any pressure. We also installed some plants in Peru. It's middle of nowhere, and the spring water comes in. There is no electricity. You just need some kind of fixed bed reactor. Means some kind of. We made it with a simple PVC pipe, something like a column, and we filled it with the activated carbon, our media with protein fibers inside, and the water comes from the mountains. It goes through this one. They have 100 times above than the WHO drinking limit of arsenic in their natural water. So that this granulated media will be used without any constraints. And also, like for the developed countries, we also introduce a new product. It will be launched maybe in 1 or 2 months. It's a cartridge. So that especially in the household sector or even in the water treatment plants, you have a simple cartridge you can put inside, and then you can open your tap and then it will do the filtration without you don't need any pump, you don't need any energy, you don't need anything special. It's just like you have a coffee machine and then you put a coffee tablet in it and then you have coffee like that. We like to make a device which is connected to the sink or under the sink. You just open it and then without any external pressure and external things, the filtration will work. So we develop these products because of user comfortability and easy to use for their purpose.
So basically, your two existing products and the one you're going to develop seem to me like they tell the story of your company. You started with a membrane in the filter press. So I guess it's more on the sludge line on the wastewater treatment. So it's where you want to recover the heavy metals, and then you might then be able to take out these metals and to reuse it. Then you found out that there's something to do with water. So where to address the broader market for water. And that's where the granulates come into play. And now you're wondering if you could bring that in the household. So that's why there's the cartridge.
Yes, exactly. You got my point. Yeah, yes.
So the protein itself is targeting the heavy metals, but the fact that you combine it with activated carbon means that you have also the adsorption capacities of the activated carbon. So basically, do you say that you address every type of pollutants, or is there still something you cannot address?
The protein fibers, it not only bind heavy metal ions, it can also remove some organic pollutants. We also published a recent article how protein fibers will remove some pesticides from pharmaceuticals, because pesticides, they use it in the water and then for the agriculture purpose, and then it will go from the fields to the rivers, and then your water is finally contaminated with organic pollutants. So these protein fibers not only bind heavy metal ions, it can also bind some organic pollutants. And also we have activated carbon, which is a food grade quality, which we use it a very good quality, and it can remove the organic pollutants without any problem. And if we come to our membranes and also our cartridges, we have size exclusion mechanism, because the membrane's porosity is almost like less than 0.7 microns, something like that. The bacteria cannot pass through this one. So we have 4-log reduction of this one. In case of our cartridges, we also integrate the cartridge with hollow fibers, so that you have really a high quality drinking water at the end. And I also want to mention that not only bacteria, we modify these protein fibers on the surface to target the virus. Okay, and we filed a new patent this week, and that will remove, for example, influenza virus, just almost like 4-log reduction of virus, because it will inactivate all the enveloped virus. We did a recent study including the current problem of coronavirus, and I'm happy to share as a preliminary step. Nobody knows about it, but it can inactivate COVID virus as well. That is our breakthrough, what we find it out very recently during the COVID season.
So you inactivate it from water?
Yes, exactly. We can inactivate the virus. Basically, we didn't understand the complete mechanism, but water, which is having a virus in the inlet, and if you see the virus activity in the outlet, the media, our material, which is having the protein fibers modified one, which can inactivate the virus as well.
Okay, fascinating.
Yes, that is our new research progress on it.
You mentioned just before that you already have some plants or some places in the world where you are using your medium. Can you tell us a bit more at which stage you are? What are those projects?
Yes, we did several pilot studies starting from Europe to South America, Asia, and even in US. So including Australia, and means we did several pilots. Just to mention, especially in the drinking water in South America, with the help of Swiss Embassy in Peru, they realized that the arsenic problem in the drinking water is almost like 100 times above than the drinking limit. There was a national emergency because of this arsenic in their groundwater, and we did the pilot study almost 1 year, because we want to see what is the long-term performance, what is the capacity, and how is the user comfortability to use it in the household, in the treatment plants. And also it was installed in a drinking water treatment plant. It is running. And to mention that even in Europe, one of the major city in Italy, they have the municipal drinking water treatment because of the volcanic region. They also have arsenic. It's not very high, but within the limit, means 5 to 6 times above than the drinking limit. They use currently with other adsorbent, and we run the pilot with our material, with our membranes as well. And then we show that the efficiency is so high, the capacity is very high. And basically we provided the material to them, and they did their own measurements. They conducted the pilot, and they sent us the report. And like this, to mention, we did it some mining water treatment plants. For example, to recover expensive metal like gold, silver, platinum, and we know how efficiently and how efficient for the mining. It's like a win-win situation in the mining sector because they use our material. The amount of the precious metals they recover is unbelievably high, so they don't have any problem. And recently, I want to mention that the clinical wastewater, especially which is having the radioactivity, because they use these radioactive nuclides for the therapy and the diagnosis. And the patients, whoever in the hospital, even if they go to the toilet, this water need to be collected in a tank because it is radioactive wastewater. And we did a pilot in hospital in Bern, and we can clearly show that if the water passes through our membrane, it can do almost 100 percentage removal of these radionuclides. Because some radionuclides which is having half-life of several years, and even like in Japan there was earthquake and their nuclear treatment plants are disassembling because of these unexpected reasons. Even in Germany they want to dismantle all the nuclear plants because of the risk of the radionuclides. So we did a pilot also in University Hospital in Hospital in Bern, and we want to go. We did a pilot, and now we want to try really in the Winterthur Hospital. We want to install it with not complete capacity, but we want to do one small stage plant trials, and afterwards, if it works fine, they want to adapt it to everything. And yeah, like this, we did it even the wastewater treatment in Lausanne, where they have the nickel and chromium from the electroplating companies, which can be absorbed so that they can release this water without any further treatment directly to the sewage.
Just for me to understand, when you're running a pilot, you mentioned that you put some columns with activated carbon filter with your medium. And when you go to a bigger scale, then you do a refurbishment of an existing filter just by replacing the actual filter material by your material, right?
Yes, basically we have two products. If they want to, because if it is a granulated media and when you want to change the granulated media is also not very easy. So normally they will have bigger plant with granulated media and either they will regenerate the media or they will fill it with the new media. But the other advantage of the membrane is you treat your water and then this solid waste can go as a membrane and when they put the new membrane they are ready to go. It means it's like a completely new system.
That was going to be my next question. You mentioned this 1 year piloting. Over 1 year, how often do you have to change the medium? Do you have to change it at all, or when do you change it?
Yes, that depends upon the source water because even we did several places because we choose the pollution level is one place 5 times above than the drinking limit, one place 50 times above than the drinking limit, one place 100 times above than the drinking limit. So we want to identify how frequently we need to change the membranes. Normally, the media, for example, in a lower contamination level, in 1 year, we never changed it. And also, if the pollution levels are severely high and they need to treat very high volume of the water, we change one time. So the idea is every 6 months, either you need to regenerate the media or if there is no toxic regeneration, means every time if you want to regenerate it, there is also next problem of secondary pollution. So basically, the change of the media is depending upon the source water and we have really high capacity compared to we also did it what is available in the existing market, what is their performance and their capacity and what is our capacity and what is our performance. We also work with EWAG, the Swiss Federal Water Research Institute. Even the scientists, they know about our technology, they know what is the benefits of our technology. So this is basically what we do it at this moment.
You mentioned plenty of pilots with promising results. Did you also move to the next step to a small scale or even a full scale plant?
Yes, we also installed in a global leader in beverage segment in the real treatment plant for a beverage production. And also we work with Swiss beverage multinational company. And we also installed it in municipal drinking water segment. We also installed in the plant scale. So slowly we are moving from laboratory to pilot to the plant now.
How do you do those moves? Do you do it by yourself, or do you partner with existing companies out there, which would be, I don't know, filter manufacturers or operators?
Yes, we have some partners, especially on the engineering part, because we cannot do everything on our own. I think no company in this world they cannot do a complete things. But we can provide the solution. Means if a company approaches, we have this wastewater. Can you please provide a solution? We partner with them, and our idea is they have inlet. We want to provide a good quality outlet which is having good water at the end. So we partner with our engineering company. That will be a mutual collaboration, and we generate an order to this company, and they will try to help us in the installation. They know how our media and how what is the advantage with our things. So our means we can provide not only our filter or granulated media, but we can provide the complete solution.
You mentioned EAVAG. In Switzerland, there's this full topic of micropollutant treatments, which is ongoing for the past, let's say, almost past decade. And there are so much wastewater treatment plants that need to be equipped with the treatment to remove the micropollutants. And there was always this kind of problem that you can remove every pollutant with ozone or activated carbon, but not the heavy metals. And EAVAG has been involved a lot and looking for solutions to remove those heavy metals. And could your technology be the final addition that was just missing and that will allow Switzerland at least, and then the next countries to finally treat this problem of micropollutants?
Yes, because I want to find a single solution which can do most of the part. Means there are some technologies, there are some ion exchange designs, ultrafiltration, nanofiltration, reverse osmosis. But every technology has some positives and negatives. Means if you go to reverse osmosis, there is a lot of energy needed. Yeah, some water will go as a waste. But my idea is I want to provide a sustainable water treatment which can filter not only a specific problem, but because water is not always come like as a lab water. The real wastewater will be mixture of everything. So our idea is even if it is having micropollutants, even if it is having heavy metal, even if it is having bacteria, virus, and this thing, we want to provide a single stage solution which can really very effective and efficient and with a low maintenance cost. So I'm pretty sure we have a solution. We are trying to understand it because every water chemistry is very different. If you go to water in Peru, if you go to water in Switzerland, even within Switzerland, the mountain region have different water chemistry, and the lake water have different water chemistry. So water is very different from place to place. So the idea is we want to remove micropollutants, heavy metal ions, bacteria, and everything with our one media or one membrane or one catalyst solution.
You mentioned that every technology has its limitation, which is fully true and fully normal, I would say. What is the limitation of your technology? Is it a limitation linked to very large plants where I could imagine that maybe footprint might be an issue?
You see, means the first part, what is best part of our technology is we use a food grade material, which is a whey protein, which is eatable. And we also use activated carbon, which is also a food grade quality. And the complete manufacturing is a wet processing without any plastics in the manufacturing. And in terms of sustainability in the maintenance part, we can work by gravitational pressure, means we don't need any energy. in terms of if we have a granulated media. If we use cartridge, if we use membranes, we need a certain pressure. Means it will be easily possible by a simple pump because we need a differential pressure of 1 bar maximum, which can already work with our membranes and cartridges. Because there our filtration is basically a microfiltration. And the limiting factor is basically some people are allergic to the milk. Even though we are very confident that our milk protein doesn't leach at all, means we did the water coming out, what is the leaching from this one? And we are 100% sure it is not only tested by us, it also tested by a major beverage company what is the leaching of this milk protein, and we are 100% sure that it doesn't cause any allergic properties from the milk because we tested the water coming out, coming in, and we did a lot of work and we did almost 1 year work on that one because that was one limitation factor and we can guarantee on that. Yeah, and except that, what is the limitation on our side is we don't have our own manufacturing plant. We outsource, not only outsource, we rent a facility and then we pay them on a monthly basis and we want to do the manufacturing at their treatment plant. But our future plan for our company is we want to have our own manufacturing plant and we are also looking for some investors who is interested to invest on our technology and our production because we are ready to enter to the market in a grand scale because before we want to do some pilots we want to learn from the pilots what are the limitations how to overcome the limitations from the pilots but now we are very sure we are ready to grab them.
So let me start I cannot resist. So I'm going to crack a joke that nobody outside of Switzerland can understand. But in worst case, if some of your protein is leaching, you might be having a good industrial case with Rivella because that might help them.
Yeah, exactly. Exactly.
Okay. For the ones which are not listening from Switzerland, Rivella is a very Swiss beverage where you have some milk whey inside. So sorry, I couldn't resist this one.
Yes, you are correct because we have a beverage which is made up of the milk protein.
You've mentioned many kind of applications where your technology could fit, but if you had to choose one sweet spot, where would it be? Is it really drinking water or is it more on the wastewater, industrial wastewater side? Because you really have many applications, but I guess if you don't want to spread yourself too thin, you will have to target something at the beginning. So what would be your ideal sweet spot?
Yes, basically we have strategic meeting on this one because we have plenty of applications with our technology. But our first part to enter the market is we want to find where is the low hanging fruit because we are a startup and especially the wastewater treatment is we know and we have some experience on it. That is our sweet spot. And I want to mention that we had an initial discussion. We want to start from ETH wastewater. Especially, they have plenty of labs, and means if we can do because it's an ETH technology, it's an ETH spin-off, and it's an ETH brand on it, and we want to find a solution to our ETH initially. Yeah. And because it will reduce a burden to the treatment plant at the end. Means if you really solve the problem at the source, then it's easy for the treatment plants as well. So this wastewater treatment is our current focus. But drinking water, beverage treatment, we are ready to go. We have the product ready to use it, and we don't have any limitation. And especially the complicated radioactive wastewater treatments, which is not possible by any technique. Honestly speaking, they don't have any solution for this one at this moment. Many hospitals doesn't have any wastewater treatment. They just store it until that radioactivity is completely gone. And once the radioactivity is completely gone, they will discharge it to the sewage water. So we want to target the complicated wastewater treatments And also we are open for many other sectors as well.
Talking about compounds which are difficult to treat, there is one which is particular concern nowadays, especially in the US, which is PFAS, so those perfluorooctanoid acid, which are really difficult to treat. And when I say difficult, it's still an understatement. Did you have any experience with your technology on PFAS?
Yes, we know about this problem since 2-3 years since we started. And we have one PhD who is completely focused on this topic. The major problem with PFAS is not only treatment, even the measurement of PFAS, PFOS is not so easy. You need to have really clean room because PFAS, PFOS is everywhere. Even in the laboratory scale water, you can see this kind of small organic molecules, which is very complicated to measure it as well. And we have, honestly speaking, we are going to Germany to measure it. We even in very high-end water research institutes in Switzerland, we tried to measure it, and it was not very easy. And we tried to find some groups who are really specialized for this one. They know how to quantify it, and we already did the preliminary test. We can solve this problem with our membrane because activated carbon is also can do a certain job to remove it. But it's very complicated to understand it. What is the role of the protein fibers in removing the PFAS, and what is the role of activated carbon to remove this one? So, and also the corona period, which doesn't make us a lot of progress on this project. But I'm pretty sure we will have very scientific data to show and to prove and to understand it, how to solve this problem. I'm pretty sure many research groups are trying to work on this problem. But the problem is that even the research facilities, they need to get upgraded on this subject.
So on your end, it's work in progress, but as you have a PhD student working on it, I guess if we track the scientific publication, I guess you're going to explain a bit more what you might find.
Yes.
So
Yeah. Even the means we also publish it, whatever we learn it from the pilots, whatever we learn it from the labs, because we are basically researchers as well. So even the hospital wastewater treatment, we submitted an article, and also the pilots which we did it in Peru. Everything will be communicated and make it available so that the knowledgeable reader can understand it, how the technological part of the solution.
So just to synthesize this deep dive, if I get it right from the two last questions, today for you the sweet spot might be in the decentralized wastewater treatment, because there you can really bring a help to specific problems. That's what you mentioned, for instance, with the hospitals or with specific industries. And then also on the drinking water end, as you're moving to the households, I guess that's also into this decentralized world, because your technology allows for something which is not really, which doesn't have to be in the big plant, which can be also really targeting a specific problem at a specific place, right?
Yes. I just want to mention that many existing wastewater treatment plants, they have problem with heavy metals, but they don't communicate because they don't have a solution, or it's a very costly solution. That is what I observed it from many big companies as well. When I try to communicate with them, they don't disclose it openly because they want to keep it secret until they find a solution. Especially with metal ions, because some metal ions, even in micrograms per liter, is toxic, and it's not very easy to remove it. The normal wastewater treatment plants, if they change it from existing activated carbon media to our activated carbon media, it not only remove color, it will not only remove the odor, it will not only remove the organic pollutants, and additionally, it will also remove the heavy metal ions, which is in the dissolved form inside the water. That is what we want to focus.
And that makes for a very good summary for this deep dive. So if it's fine for you, I propose you to switch to the last part of this interview, which are the rapid fire questions.
It's time for the rapid fire questions.
So short is supposed to be the way, but if you need to elaborate, don't worry, the microphone is still open. I'm not cutting you. So first question, what is the most exciting project you've been working on and why?
Yeah, as a researcher, I did several projects. I published several papers in different areas. But this is the project where I can bring the technology from lab to real world, and I can also save people's life, and I can also make a business case out of it. So that makes me more exciting about this project.
So the project is your company, right? BluAct is the project.
Yes, exactly.
Okay.
Yeah, the water treatment by using milk protein fibers.
What is your favorite part of your current job?
The current job is means as a researcher, we are just like in the laboratory. But when it is coming to the current project, we meet a lot of people. We will also understand a lot of variety of problems because every water problem is very different. And meeting new people is means we say, oh, there is also problem. There is we whether it works or not, and also like traveling with different area people that makes me more exciting in this one means not only lab scale things but in the real scale things.
What is the trends to watch out for in the water industry?
The trends to watch out, yes, I think the people need to be open and they should not wait until the solution is there. And the trend means basically because it's so big and they need to speak about this heavy metal problem openly that will effectively find a solution. Means if they don't communicate in the water industry, this heavy metal problem is not well known. So we need to be more communicative as well.
So the trend is around heavy metals, and your recommendation is to communicate about it, to find the solution and to be solution oriented rather than just putting it aside and hoping that no one notices.
Yes, exactly. That is what I want to see in the water treatment industry and in the market especially.
That's a nice one. Do you have sources to recommend to keep up with the water and wastewater market trends?
I will get several newsletters from different continents. Even I also attend several exhibitions like Field Tech in Germany. And things I follow it up. I also write some review articles on the scientific side. There are several of them, and means I follow many of them, and but it's also not very accurate. I feel, but I cannot judge because I am too young for this market.
You now have some experience with designing products with your company. So what is the thing you care the most when you design a new product or a new solution? And what is the thing you care the less?
My major priority for the product is the quality, of course. The robustness, how robust, because every water is very different, every customer is very different. So we want to find a product which will be very robust and very easy to use. You don't need an engineer to use your product. I want to have someone, even a driver of my car, he can fit the household water treatment to his sink. So I want to make a product which is easy to use. You don't need a specialized engineer to do maintenance or something. Just a common man can also work in the treatment. Just open this valve for this 10 minutes and then your water is clean, something like that. And what is means what I don't care about it much is we worked on the technology almost for 10 years with different metal ions. How the product will work, how the technology really works. On the technology side, me and my professor and whoever worked with me, they know. And even a bachelor student who worked with me, this technology, we don't have any doubt. So on the technology side, I'm not, means I know the each and every detail, means how does it behave. So that is what on the product side, business side, what I really do.
Sreenath, it was a pleasure talking with you. I think it was very interesting, at least for me. I learned many things. So I hope that our listeners will learn also at some point a lot of stuff about your company. If they want to discover more on you, where should I redirect them?
Yeah, it's our website. It's BluAct. Means I just want to tell you, Blue means water, act means action, water in action. Means in our company name, Blue means without E, BLUACT, BluAct, www.bluact.com. And
Wonderful. So BluAct, Blue Action, so Blue BLUACT.com. I'm going to put, of course, like always, all the links in the episode notes. Thanks a lot, Sreenath. And maybe talk to you in a couple of years when your company is the next big thing in water and wastewater treatment.
Thank you so much for this podcast. And I am really happy to have a conversation with you. And I hope even the listeners will enjoy our conversation.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.